All right, guys, this video will cover lesson 4.1, graphing linear functions using tables. This starts on page 209 in your workbook. I do not have video on because I'm filming this from home and I have no makeup on and my hair's not done. So there, at least I'm not making you look at the ceiling. Today's goal is to graph linear functions by making tables and also to graph linear functions by using the x and y intercepts. Okay, next page. Example 1, graph by making a table. They've given us an equation, negative 2x minus 3 equals y, and they want us to make a table. All right, so what they're doing is they're saying you can choose values of x, substitute them in the expression, and get the value of y. Then you take the x and the y to make an xy coordinate point, and after you have several of these, you can successfully graph the line. So let me get a pen fired up here, do some math. Pen. All right. So what they want you to do is, here they've given you negative 4 for x. So you're going to substitute negative 4 in this expression, right there, minus 3. Well, negative 2 times negative 4, I'm using the order of operations, obviously, would give me positive 8. Positive 8 minus 3 gives me 5, which gives me the coordinate point negative 4, positive 5. This value is the x value, this is the y value. All right, now I'm going to substitute negative 2 for x. Negative 2 times negative 2 minus 3. This is positive 4 minus 3 would be 1. Giving me the point negative 2, 1. And you continue to do this, negative 2 times 0, minus 3. This would be 0, minus 3 is negative 3. This gives us the coordinate point 0, negative 3. And then you substitute 1. Okay. Negative 2 times 1 is negative 2. Negative 2 minus 3 is negative 5. It gives us the point 1, negative 5. And then we substitute 3. We have negative 2 times 3 minus 3. This gives us negative 6. Negative 6 minus 3 is negative 9. So we would have 3, negative 9. And then you would just go over here and graph the points that you found and graph the equation. It's time consuming, I get it. Okay, here we have y equals 2x plus 5, okay? So we're going to substitute these values in for x. So we're going to be using 2x plus 5. In the first one, we substitute negative 5 for x. So we'd have 2 times negative 5 plus 5. Well, 2 times negative 5 is negative 10, and negative 10 plus 5 is negative 5. Okay. For the second one, we're going to substitute negative 3. Well, 2 times negative 3 is negative 6, and negative 6 plus 5 is negative 1. The next one, we're going to substitute negative 1. 2 times negative 1 is negative 2. Negative 2 plus 5 is 3. Now we're going to substitute 0. So 2 times 0 plus 5. Well, 2 times 0 is 0. 0 plus 5 is 5. And now we're going to substitute 2. When left to my own devices, I generally will only pick 3 values for x. They're going a little over the top. 2 times 2 is 4. 4 plus 5 is 9. You don't really need more than 3. If you get 3 and they're all in a straight line, you generally got the right 3. So now we're going to graph these, and you'll notice that these are graphed. This graph is set up so that each line is 2, is a value of 2. So we're going to have to estimate here. Negative 5 would be like right in between these two, and then right in between these two. So we're looking at a point right smack in the middle of that box there. And then negative 3, negative 1 would be right there on the, there. Negative 1, 3, negative 1, 3, be like right here. And 0, 5 would be like here. And 2, 9 would be like here. And now it gets really funny because now Miss Williamson tries to draw a straight line with a graphic drawing tablet, which is not a pretty sight. Yes, I know, it's bad. But if I had a ruler on regular paper and pencil, that would have looked fabulous. It would have. All right. I'm sure that this is probably already familiar to you because a lot of you have probably done this in ALEKS, but I'm going to stick with the book and review this just in case there are kids who don't know how to do this. All right, so here's another table. Now, the point they're trying to make here is that you want to choose appropriate domain values. That means choose smart values for x. If you've got a coefficient of 1/4, you want all of your values of x to divide evenly by 4. All right, so you don't end up with messy fractions. Nobody wants to have to graph a fractional coordinate, okay? And this will save us from that. 1/4 of -8 plus 3. Well, 1/4 of -8 is -2, and -2 plus 3 is 1. So that gives us the point -8, 1. 1/4 of -4. 1/4 of -4 is -1, and -1 plus 3 is +2. Okay. 1/4 of 0 is 0, and 0 plus 3 is 3. Okay. So that gives us 0, 3. 1/4 of +4 plus 3. 1/4 of 4 is 1, and 1 plus 3 is 4. Kind of see the pattern here. Some of you would maybe get lazy and just write 5 here. I'm tempted, but 1/4 of 8 plus 3. 1/4 of 8 is 2, of course, and 2 plus 3 is the 5 we expected to get. We would have 8, 5. Then you come over here and you graph the points. -8, 1 would be about here, and you'll notice I've already got this line here. And -4, 2 would be about here. I'm making the line work for me. 0, 3 would be like here. 4, 4 would be here. And 8, 5 would be roughly here. Okay, and so then you draw your line, or let the program draw the line, so it's straighter. Okay. So obviously I've already put the line on this one too. We're going 3/5 of x minus 2. Now I can keep writing out these equations over here. 3/5 of x minus 2. All right, but I kind of think you could probably do it mostly in your head. 3/5 of -10. Well, 1/5 of -10 would be -2. 3 of them would be -6. And -6 minus 2 is -8. All right. I'll do one just to show you what I'm doing, but then I think the rest of them I'm going to do them in my head. This would be -10 minus 2. So you would, in a calculator, if you need to, 3/5 times -10. I'm telling you that will give you -6 minus 2 is -8. So that's what I'm doing in my head. Now, 3/5 of -5 would be -3, and -3 minus 2 is -5. 3/5 of 0 is 0, minus 2 is -2. 3/5 of 5 would be 3, and 3 minus 2 is 1. 3/5 of 10 would be 6, and 6 minus 2 is 4. So we would graph -10, which would be all the way to here, and then -8, which you can see, I've got the line where I need it. -5, -5, 0, -2, 5, 1, and 10, 4. Put your arrows on your line. It should extend beyond that. Okay, not too bad. What's up next? Okay. Now, they want to talk to you a little bit about vertical and horizontal lines. When you have y minus or equals some number, like say 3, and x equals 3. These are horizontal and vertical lines. This is your x-axis. This is your y-axis. If x is 3, you would go 1, 2, 3. Here, x is 3. It's also 3 here and here and here. It's also 3 here and here and here. So this is going to be a vertical line at x equals 3, because every single point on this line has a 3 for the x coordinate. Same thing with y. If we do y is 3, we go 1, 2, 3 and put a line here. But isn't this also a y coordinate of 3 and a y coordinate of 3? This would be like 1, 3, 2, 3. This would be negative 1, 3, negative 2, 3. So you can see that every single point on this line has a y coordinate of 3. So this is always going to be a horizontal line, and this is always going to be a vertical line. Now this is a bunch of rigmarole to try to explain to you why that's the case. They're saying, well, x is gone from this equation, and it must be because the coefficient was 0, because 0 would get rid of it. So they're saying rewrite it as 0x plus 5 and then make a table. Well, it doesn't matter. Every time you substitute a value for x, your first thing you do is multiply it times 0, which renders it 0. Okay? So every single time you're going to get a solution of 5. Think of it this way: 0 times negative 2 plus 5. This is 0, plus 5 is 5. And every single time, you're still going to get the same result, because every time you're multiplying this x coordinate times 0. And so all of these are going to be 5s, and all of your points have different x coordinates, but they all have the same y coordinate. Y is 5, always, always, which makes a horizontal line. Okay, 1, 5, and 2, 5. And when you go to graph this, all right, negative 2, 5. All right, they would have to give us this 2 for thing. Negative 1, 5, 0, 5, 1, 5, 2, 5. You can see we're getting a horizontal line at y equals 5. Now we have x equals a number. Whenever you have x equals a number, you're going to have a vertical line. Where is x equal to negative 2? Right here. Okay? Where else is x equal to negative 2? Well, this is negative 2, 1, negative 2, 3, negative 2, negative 1, negative 2, negative 3, or negative 2, negative 2. This is a vertical line at x equals negative 2. So x equals 6. Well, where is x 6? 1, 2, 3, 4, 5, 6. Hope I counted those right. 1, 2, 3, 4. And you get a vertical line at x equals 6. Those are easy. Another way we can graph linear equations is to find the x and y intercepts. Okay, almost all lines intersect x and y. Now, exceptions would be vertical and horizontal lines. They only intersect one of the lines. But you can use x and y intercepts as another means of finding 2 points to graph a line. All right, so they're saying to find the x-intercept, let y equal 0. It's always a thing. If you're trying to find where it intersects x, y would be 0. If you want to find where it intersects y, x will be 0. Okay, so to find the x-intercept, you let y equal 0. To find the y-intercept, you let x equal 0. Okay. Now, if we take this equation and we substitute 0 for 2, or for the y, I mean, we're going to have the original equations, what they want you to write here. So negative x plus 2y equals 8. And then they want you to replace y with 0. Negative x plus 2 times 0 equals 8. Simplify. Well, 2 times 0 is 0. So now we have negative x equals 8. But we don't want to know what negative x is, so we're going to multiply both sides of this equation by negative 1. That just makes x positive, and we now know that x is negative 8. So the graph intersects the x-axis at negative 8. Okay? To find the y-intercept, we let x equal 0. So we write the original equation, negative x plus 2y equals 8. We substitute 0 for x, negative 0, no such thing. 0 is neither negative nor positive. But this is gone now. So we have 2y equals 8. And then we would divide both sides by 2, and we get that y is 4. So this means that the graph intersects the y-axis at 4. Okay? So it intersects x at -8. It intersects y at 4. And ta-da! We have an ugly virtual line. But that works too. Okay, so here we have this equation. We have 4y equals -12x plus 36. If I'm going to find the y-intercept, I will let x equal 0. So I will have 4y equals -12 times 0 plus 36. This is going to be 0. So 4y equals 36. Divide both sides by 4. And we get y equals 9. So it intersects the y-axis at 9, which would be right here. Okay. Now we take the same equation, 4y equals -12x plus 36. Okay, I thought it was recording, but I lost my picture for it. I'm like, wow, is this really recording? Yes. I don't see my controls here. Okay. Come on. I'm like a YouTuber going, is this really recording? Okay, so y equals 0. All right, we're going to substitute 0 for y. So we would have 4 times 0 equals -12x plus 36. Okay. And this will become 0. So now we have 0 equals -12x plus 36. We can add 12x to both sides, and we get 12x equals 36. And then we would divide both sides by 12, and we get that x is equal to 3. Okay. So where x is 3 is right here. And our line is, yeah, I mean, it's the best I can do with this graphic tablet thing. All right. Next. Okay. Let's see. Oh, this one's involved. This is a recipe. They're trying to make it into a word problem. Here's our equation right here. Y equals 5/2, x equals 60. Okay. They're telling you Angelina bought a 15-pound bag of dog food for her dog. The bag contains about 60 cups of food, and she feeds her dog 2.5 or 5/2 cups of food per day. The function y plus 5/2 x equals 60 represents the amount of food left in the bag after x days. Graph the amount of dog food left in the bag as a function of time. Well, they've already done the graph for us. But to find the x-intercept, let y equal 0. All right. To find the y-intercept, let x equal 0. Okay. So the original equation is y plus 5/2 x equals 60. Never wants to write the other line on the equal sign. If y is 0, then that's just 0, and we have 5/2 x equals 60. To get rid of 5/2, we multiply both sides by the multiplicative, the reciprocal, and that would be 2/5. We just take that 5/2 and flip it over. And then we simplify, and we end up with, now, what we're going to do here is we're going to, let's see, 5 and 60, that becomes 12. 12 times 2 is 24. You could have done that in a calculator if you really don't enjoy fractions. So the x-intercept is 24. That means the graph intersects the x-axis at 24. So after 24 days, there is no dog food left in the bag. We do the same thing to find the y-intercept. All right, when x is 0, x is the number of days. So basically, before she starts feeding the dog, she obviously is going to have 60, but we go through the motion anyway. Write the original equation, y plus 5/2 x, I wrote that badly, sorry, equals 60. Okay. And then if x is 0, this is gone here. So now we just have y equals 60. And I'm doing this on the wrong line, but you get what I'm saying. So the y-intercept is 60 because that's how many cups of dog food she started with. And here the x-intercept is 24, which is how many days it will take her to exhaust the bag. Okay. Next, we have a peanut farm. A farm produces about 4,362 pounds of peanuts per acre. 1 cup of peanut butter requires about 2/3 pound of peanuts. If 1 acre of peanuts is harvested to make peanut butter, the function y equals negative 2/3 x plus 4362 represents the pounds of peanuts remaining y after x cups of peanut butter are made. So the x-intercept and the y-intercept. Well, the x-intercept is when y is 0, okay? So the x-intercept is going to be when you run out of peanuts, okay? When you have made as much peanut butter as you possibly can make, okay? Let's see, and the y-intercept is before you have used any peanut butter, okay? Well, before you've used any, you have 4,362 pounds of peanuts, all right? What we need to know is when do we run out of peanuts, okay? So to find the x-intercept, we want y to equal 0. Negative 2/3 x plus 4362. Oh, I feel a need for a calculator here. Let's see. Well, right away I can eliminate b because then you draw a line. That can't be right. Plus, I know that the y-intercept is 4362, so it's got to be one of these two down here. All right. The question is, when do we run out of peanut butter? Let's see. So we could add 2/3 x to both sides. 4362. Now, I love fractions like as well as the next person, but there comes a time when even I say, let's go for the calculator because I really don't want to work with this big of a number. So let me grab my calculator. All right, and yeah, this recorder is behaving strangely in that I don't see the controls, and so I'm not really even sure how to turn this off when I'm done recording. It's gonna be an experience here. Okay, 4362 times 3/2. And we're getting that x is equal to 6543. So we're looking for the graph where the line intersects x at 6543. This one is clearly wrong. C is the only possible solution. It intersects y at 4362. And it intersects x at 6543. So which one uses the equations correctly? C does. Oh, that brings us to the end. And the secret word for this video is Chihuahua. I myself am a lover of Chihuahuas. I have had Chihuahuas for many, many years. Right now I have a long-haired white Chihuahua named Trixie. She is the love of my life. And now I need to figure out how to turn this recording off because, how do I turn it off? Let's see. How do I tell it to stop? Okay. Click here to pause.